Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and your studies are also going on well. This is part 7 video on the chapter of rational numbers, where I will solve some selected problems from the exercise 1C from the textbook of author RS Aggarwal. This exercise 1C is based on addition and subtraction of rational numbers and their properties and the concepts of additive inverse and additive identity. So this video is part of the playlist CBSE Maths 8 for RS Aggarwal, where I discuss the chapters of mathematics of class 8 from the textbook of RS Aggarwal and solve the problems of the exercises and the MCQ and the test paper at the end of each chapter. If you have not watched the previous 6 parts, I strongly suggest that you watch them also to maintain the continuity of your study of the chapter rational numbers. So let's get started with this video. Okay, so I have the exercise 1C problems on the left hand side, and on the right hand side I will solve the problems. I will not solve all the problems, just 2 or 3 from each problem. So there are multiple parts of each problem. I will do 2 or 3 which I have not done, because in the previous video as illustrative examples I have solved some problems from this exercise. As you can see, they are tick marked. But I will cover all the problems that will cover the most variants of problems that can come from this from the concept of addition and subtraction of rational numbers. So there are 14 questions. I will try to do most of them, let's see, but I will not repeat the same kind of problems. Okay, so let's start from the first problem. Let's do, this is add the following rational numbers, where you can see all the rational numbers have same denominator. Even though this is pretty simple, but anyway, let's do 2 of them. Let's do, we have to add minus 2 by 5 and 4 by 5. Remember that in doing addition and subtraction of rational numbers, if you see any rational number having negative denominator, always make the denominator positive. Okay, so this is what, nothing but we just add the numerators. We add the numerators and the denominator remain the same. So this is minus 2 plus 4 by 5. This is equal to 2 by 5. This is simple. Let's do another one. Let's say let's do this was part 1. So while I am solving the problems, you can pause the video and take a screenshot for your future reference. So part 5 is 5 by 6 plus minus 1 by 6. So we just add the numerators. This becomes 5 plus minus 1 divided by 6. This is 4 by 6. Now whenever you do additions and subtractions, or you simplify, given an expression, you are asked to evaluate or simplify an expression of rational numbers having addition, subtraction, multiplication or division. Whenever you get the final result of the rational number, always try to make it in the standard form. So this rational number 4 by 6 is not in standard form. We have to divide both the numerator and the denominator by the HCF, which is 2. So this becomes 2 by 3. So this 2 by 3 is in standard form. Okay, now let's move on to question number 2. This is about addition of rational numbers having different denominators. So let's do part 2. So we have 5 by 8 plus minus 7 by 12. So when adding to rational numbers having 2 different denominators, we need to find the LCM of the denominators. So we have to find the LCM of 8 and 12. So how do we find the LCM of 8 and 12? We do like this. We take the largest, I guess we should take the largest number which divides both. So if we take 2, 4, this is 2 and 3. So the LCM becomes 4 into 2 into 3, which is 24. The LCM of 8 and 12 is 24. Okay, so now we will add 5 by 8 plus minus 7 by 12, where we have to convert them to their equivalent form, so that both the equivalent form have the same denominator as 24. So this becomes 5 by 8 will become, I am directly converting them. I will not explain very detailed steps. For that you can please see my theoretical video, that is part 6. So when I convert 5 by 8 so that the denominator is 24, it becomes 15 by 24. Similarly, when I convert minus 7 by 12, the rational number minus 7 by 12 to its equivalent form, so that the denominator is 24, it becomes minus 14 by 24. I am prone to make mistakes. If I am doing any kind of mistakes and my answer is wrong, you can please let me know in the comment section. I will highly appreciate that. Okay, so now we have the rational numbers with same denominator. We just add the numerators. 15 minus plus minus 14 divided by 24. This is 1 by 24. So let me circle all the answers that I am getting. Okay. I will not do any more problems. What is 9? Add the following. 0 and minus 2 by 5 is same. When you add 0 to any rational number, the result is that rational number itself. Okay, let's move on to question number 3. Now this question number 3 is asking verify the following. Let's take the part 1. Verify the following. It is saying to verify whether minus 12 by 5 plus 12 plus 2 by 7 is equal to 2 by 7 plus minus 12 by 5. Now I am not sure whether it is asking to verify by evaluating both the side, that is you evaluate LHS, you evaluate RHS. If you consider this value, whatever this value will be as LHS, and if you consider this, whatever the value will be as RHS, and then you will verify whether the LHS is equal to RHS or not. I am not sure whether this is the way the question is this problem is supposed to be solved. But what I have in my mind is that this is addition, both the sides, LHS and RHS are addition of two rational numbers, and I can see clearly that the LHS is if you consider minus 12 by 5 as the rational number P by Q, and if you consider 2 by 7 as the rational number R by S, I can clearly see LHS is equal to P by Q plus R by S. And what is RHS? RHS is equal to R by S plus P by Q, which is definitely equal to LHS from the commutative law. Commutative law of addition. Addition of rational numbers satisfies the commutative law. So from this we can directly say that LHS is equal to RHS without actually evaluating the value of both the LHS and RHS. So this is the way I would like to do. So okay, so let's do another part. As I said, I will not do all the parts of a problem. I hope doing one or two parts, it will give you a good amount of help or concept or understanding how to apply the concepts to solve the problem. Okay, so part 4 is 2 by minus 7 plus it is asking to verify whether 2 by minus 7 plus 2 by minus 35 is equal to 12 by minus 35 plus what is this, or 2 by minus 7. Now this kind of problem, you can clearly see that I see both the same rational numbers on the left hand side and on the right hand side. The order is changed. It is just that the order is changed. Now to solve this problem, if you first convert the rational numbers to have positive denominators, and then you simplify the LHS, simplify the RHS, and you evaluate and you test the equality of the two values, I think that will be a redundant way of solving. It is time consuming and this problem can be straight away, this equality equation can be straight away verified using the concept of commutative law of addition of rational numbers. So I am directly saying the commutative law, because if you see, if you consider P by Q as 2 by minus 7 and R by S as 12 by minus 35, we can clearly see that LHS is equal to P by Q plus R by S. RHS is equal to R by S plus P by Q, which is equal to P by Q plus R by S. Why? Because commutative law or commutative property. Commutative, it's better to write commutative property of addition. I think it's sufficient to write commutative property addition of rational numbers. Wherever I write RNS, it means rational numbers. Now what is P by Q plus R by S? It was LHS. So we verified that LHS is equal to RHS. Okay, let's move on to question number 4. Question number 4 is also verify the following. This time we will have to use the associative law of addition. Associative law of addition. So the first one is 3 by 4 plus minus 2 by 5 plus minus 7 by 10. Now one way you can do verify, you can solve this kind of problem, that is verify, is that you can, from this you can say the LHS, it's better to write LHS equal to this. Now this you can write as 3 by 4 plus, you can change the grouping. In the first case, the given problem, the given expression, the grouping was between first and second rational number. Now I can change the grouping. Since addition of rational numbers is associative, I can change the grouping. I can change the grouping. I can group the second and the third rational numbers. So I can do this. This will be equal. It is better to write associative property. Actually, it is associative property of addition of rational numbers. I am not writing all that. I hope you will understand. Associative property, using associative property of addition of rational numbers. Now what is this? What was given to prove? This is RHS. That is the RHS of the given equality to prove. Okay. So all the parts will have, you can apply the same concept using associative property or associative law of addition of rational numbers. Let's do part 3. So what is LHS? In the given equality that we have to prove, what is LHS? LHS is minus 1 plus, it is minus 2 by 3 plus minus 3 by 4. Okay. So this we know, applying associative property we can change the grouping, that is we can group minus 1 plus minus 2 by 3 and then leave the minus 3 by 4 alone. This is using associative property. But you should write, I am not writing it the full sentence that need to be written. It should be associative property of addition of rational numbers. Now what is this? This is nothing but the RHS of the given equality to prove, hence it is proved. Okay, let's move on. I hope you are pausing the video and taking screenshots if you think it will be beneficial for you as a future reference. Let's move on to question number 5. These are fill in the blanks questions. These are also based on the application of properties of addition and subtraction, that is associative law, commutative law, and mainly associative law and commutative law. Okay, so let's do the first part 1. Fill in the blanks. So minus 3 by 17 plus minus 12 by 5 is equal to minus 12 by 5 plus, we have to fill in the blanks. What rational number will be in the blank? We have to fill it. Now clearly we can see it's an application of commutative law of addition of rational numbers. Now you can solve like this. You can say LHS is equal to minus 3 by 17 plus minus 12 by 15. Now you can say this as minus 12 by 5 plus minus 3 by 17. Why you can say this? Using commutative law. My machine is running slow. I have no idea why. If this machine is not a this machine does not have good specification. It has only 4 GB RAM and dual core processor. It struggles. Anyway, commutative property. Using commutative property of addition of rational numbers, we can say that the given LHS is equal to, we can write this. Now what is this? So now in the fill in the blanks, now this implies from the right hand side of the given equality in the fill in the blanks, if you compare, let's say I don't know exactly how to solve it, what should be the exact steps. You can consider, let the fill in the blanks, let the rational number in the fill in the blanks be x, or you can say a by b or p by q, whatever, it does not matter, x. So this implies that minus 12 by 5 plus minus 3 by 17 that we have derived from the LHS should be equal to the RHS, the given RHS, that is minus 12 by 5 plus x. X is what we have assumed. Now this implies we can cancel out both these rational numbers and we get x equals to minus 3 by 17. Now why did I cancel? I hope you are aware of the fact that this is true for any numbers, any number system, fractions, decimals, integers, rational numbers, natural numbers, whole numbers, integers. It is that if you have an equation of the form c plus a equals to c plus b, where c is some non-zero number, you can cancel c from both sides. I can say that a equals to b. So this is exactly what I did. I cancelled out minus 12 by 5 from both sides and we got x equals to minus 3 by 7. So hence the answer is minus 3 by 17. So the fill in the blanks, we have to fill the blank with the rational number minus 3 by 17. Okay. Let's see part 5. It is saying 19 by minus 5 plus minus 3 by 11 plus minus 7 by 8 is equal to 19 by minus 5 plus there is a fill in the blanks. I am considering the fill in the blanks to be x. I am underlining the x because that was the fill in the blanks that was asked to be filled. So this is given. If this is the case, then what will be x? We have to find. Okay. So let's say what is LHS. We have to, the basic idea is that either you rearrange the LHS expression to look similar to the LHS expression, or you transform by rearrangement of rational numbers, you transform the LHS to look like RHS, and then you will compare the given LHS or RHS with yours. So let's say I am trying to transform the given LHS by using rearrangement of rational numbers to look something similar to the given RHS. So this is the LHS expression. Now you can clearly understand that we have to apply the concept of rearrangement of rational numbers. We can always rearrange properly using appropriate properties of addition and subtraction. Not subtraction, actually addition. So we can use associative law of addition of rational numbers. So I can change the grouping. In the LHS, the given grouping is between second and third rational number. I can change the grouping to group first and second rational number. So I can say this is equal to 19 by minus 5 plus minus 3 by 11 plus minus 7 by 8. Okay. So I have transformed the given LHS to this one. Now this implies that it should be the fact that 19 by minus 5 plus minus 3 by 11 plus minus 7 by 8, which is the simplified form, our simplified form of the given LHS, to be equal to the given RHS, that is 19 by minus 5 plus, actually it was given fill in the blanks, but we have assumed that in the fill in the blanks the rational number we assume to be x. So we have this. Now how do we find x? First of all, we will cancel out minus 7 by 8 as I explained in the previous example. C plus a, if you know that C plus a is equal to C plus b, we can cancel out c. So in this case the c was minus 7 by 8. Okay, so this implies that 19 by minus 5 plus minus 3 by 11 is equal to 19 by minus 5 plus x. Now again we will cancel out the similar term 19 by minus 5 from both sides, and hence we get x equals to minus 3 by 11. So in the fill in the blanks the rational number will be minus 3 by 11. I hope you got the idea. You can using this concept you can definitely solve the remaining problems. Okay, let's move on to question number 6. My machine is running extremely slow. Okay, so there are a lot of parts of 5, but all the concepts I am quite sure you will be able to do it. All the problems, all the parts, if you have understood the way I am doing and the concept I am applying to solve the problems. Okay. Let's proceed to question number 6. Find the additive inverse of each of the following. Okay, so let's see what will be the additive inverse of. Additive inverse, in short I am writing as add I, means additive inverse. Additive inverse of minus 16 by minus 5. Now to find the additive inverse of a given rational number, you may first convert the rational number to have you can convert the given rational number to standard form, or at least make the denominator positive. You can do that first, or you can make the additive inverse first, and then whatever the result is you convert that result to standard form, or at least to make the denominator positive. So let's say I will first apply the concept of additive inverse. Now given a rational number, how do we find the additive inverse? We simply negate the numerator. We take the negative of the numerator and nothing else. Only we take the negative of the numerator. So I will take minus of minus 16 divided by minus 5. Now what is minus of minus 16? This is 16 by 16. So it is 16 by minus 5. Now never, always, whenever you are finding a result of rational number, always at least make the denominator positive. Probably it is fine if you do not convert it to standard form, but at least make the denominator of a rational number positive in any result. So when I will make the denominator positive, this will be minus 16 by 5. So this is the additive inverse. Minus 16 by 5 is the additive inverse of minus 16 by minus 5. Now part 8 is 0. The additive inverse of 0 is 0. It is a very important concept that 0 is the only number which is equal to its additive inverse. Okay, what else? Let's try 7. Additive inverse of minus 3 by 11. This is equal to, we will just take the negative of the numerator. Now minus of minus 3 is 3. So 3 by 11 is additive inverse of minus 3 by 11. What else can we do? Okay, let's do 15 by minus 4, 5. Additive inverse of 15 by minus 4. I am straight away applying the concept of additive inverse of a rational number. That is, given a rational number p by q, the additive inverse will be minus p by q. So this will be minus 15 by minus 4. I just made the numerator negative. Now this is nothing but 15 by 4, because if both the numerators and the denominators are of same sign, then the rational number is a positive rational number. Only when the numerator and the denominator of a rational number are of opposite sign, the rational number is negative. Okay. What else can we do? Okay, just the rest you can do it very easily, I am quite sure, but let's do it. 3. Additive inverse of minus 18. We know that minus 18 in the form of rational number p by q is minus 18 by 1. Now what is this? You take the negative of the numerator. This is 18 by 1. This is 18. Okay. Now let's move on to question number 7. Subtract. This is about subtraction. Okay. Let's do part 8. It has asked to subtract minus 7 from minus 4 by 7. So minus 4 by 7, from this we have to subtract minus 7. Now as we have studied in the previous video, part 6, that how do we subtract a rational number from another rational number? We just add the additive inverse of the rational number that need to be subtracted. That is, when we have to, in this example, subtract minus 7. Now what we have to do is that we have to add the additive inverse of minus 7. Why? Because we are subtracting minus 7 from minus 4 by 7. So we will add the additive inverse of minus 7. Now what is additive inverse of minus 7? This is 7. Now we can consider 7 as 7 by 1. So we have to do this, minus 4 by 7 plus 7 by 1. Now the denominators are different, so I'm not going to now explain all the steps that you have to take LCM of the denominators, and then you have to convert the two rational numbers to the equivalent form to have a common denominator as the LCM. I will not say all those things. I hope you will understand those steps while I am solving the problem. So this becomes minus 4 plus 49 by 7. This is equal to 45 by 7. Okay, let's do another one. Let's say, how about 7? We have to subtract minus 32 by 13 from minus 6 by 5. We have to subtract minus 32 by 13 from minus 6 by 5. Okay, so this will be minus 6 by 5 plus additive inverse of minus 32 by 13. So this is the concept of subtracting two rational numbers. I am writing it again. Let's say, so P by Q and R by S are two rational numbers, and if we have to subtract the rational number R by S from P by Q, we just add to P by Q the additive inverse of R by S. This is the basic concept of doing subtraction based on addition of rational numbers and additive inverse of rational numbers. Okay, so this becomes minus 6 by 5 plus what is additive inverse of minus 32 by 13? That is 32 by 13. Now we have to do the addition of minus 6 by 5 and 32 by 13. What is the LCM of 5 by 5 and 13? It is 65. So this will be minus 6 multiplied by 13 divided by 65 plus this will be 32 into 5 divided by 65. So this is minus 78 by 65 plus this is 160 by 65. So this is equal to how much? 160 minus 78 is how much? 2, 10, 8, I guess 82 by 65. And if it is possible that you can convert this 82 by 65 to standard form, you can please do that. I am not doing it. Okay. What else from subtraction? Let's do second one. We have to subtract minus 5 by 6 from 1 by 3. We have to subtract minus 5 by 6 from 1 by 3. So this is equal to, now I will not do the solving with as much details as I was doing until now. So this is 1 by 3 plus this is 1 by 3 plus 5 by 6. So I skipped the step that I did not write that 5 by 6 is the additive inverse of minus 5 by 6. Okay, so this is now 2 by 6 plus 5 by 6. This is 7 by 6. Let's save some space. Okay, I hope I did it correct. Let me check once again. 5 by 6 and this is 6, 2. Okay, what else? I hope you can do the rest. They are pretty same. Okay, let's move on to question number 8. Let's move on to question number 8. Using the rearrangement property, find the sum. Now this kind of problem will be a little interesting. You have to wisely rearrange the terms so that the simplification, the addition and subtraction becomes easy based on which rational numbers has the same denominators and which has different denominators. And also, okay, let me do first one. I will discuss. So 4 by 3 plus, we have to simplify this or evaluate this using suitable arrangement of rational numbers based on the properties of addition and subtraction. Okay, this we have to find. Now identify all the rational numbers. First of all, identify all the rational numbers which are same. We can see 3 by 5 and minus 11 by 5 have the same denominator as 5. So this is simple. Whenever you can see rational numbers with same denominator, group them. I will group all the rational numbers with same denominator. So it will be like this. I have grouped the rational numbers. I have merged or collected the rational numbers in a separate group which have the same denominators. In this problem, we are having two groups. It could be 3, 4, 5, 6, 7, 8, 9, 10. It could be many groups. Okay. Now I can now easily solve, do addition of the rational numbers with same denominator. The first one, it will be 2 by 3. And the second one, it will be minus 8 by 5. Okay. So now I see we have to now do the addition of two rational numbers with different denominators, and we will use the concept of LCM, finding the LCM of the denominators and converting the given rational numbers, not given rational numbers, converting the rational numbers in the addition operation to their equivalent form to have the common denominator as the LCM. So this will become 10 by 15 plus minus 24 by 15. Okay. So this is now minus 14 by 15. So this is the answer. This is the answer. This is the answer. What else? 45 by 7 is the answer. 18. 15 by 4. 3 by 11. Minus 16 by 5. I am circling all the. Okay, so I hope you got the idea. In this kind of problem of evaluation or simplification, you first try to merge all the rational numbers having the same denominators. Now it may not be always the case that you can do this. Let's see part 2. It is minus 8 by 3 plus minus 1 by 4 plus minus 11 by 6 plus 3 by 8. So you can see that there are no similar denominators. The denominators are all different, but you will realize that you can consider some denominators whose HCF is not equal to 1. For example, if you consider the denominators 3 and 6, their HCF is 3, and if you consider the denominators 4 and 8, their HCF is 4. So merge all those rational numbers whose denominators, HCF of whose denominators is not 1, it is something else, and it is not 1. Try to group those rational numbers. Now if you merge the rational number with having denominator 3 and 4, the HCF of 3 and 4 is 1. I mean, you can do that, but it will be, I guess it will be a little more it will take more time. Now the steps of calculation will be a little more. It's wiser to group the rational numbers so that in this case where all the denominators different, try to group the rational numbers so that all the denominators in the same group have HCF not equal to 1. So based on this, I will group minus 8 by 3 and plus minus 11 by 6, and the other group will be minus 1 by 4 plus 3 by 8. Now this, it will be easier to find the LCM, but with LCM will be 6. So this will be the minus, we can rewrite this as minus 16 by 6 plus minus 11 by 6. A lot of things I am not saying, I am not writing, but you can understand why I am doing so. So this will be minus 2 by 8 plus 3 by 8. So this becomes minus 27 by 6 plus 1 by 8. Now this will be what is the LCM of 8 and 6? I think it's 24, but let's find out. 2, 2, 3. So LCM of 8 and 6 is equal to 2 into 2 into 3, which is equal to 12. How come? I did a mistake. This will be 4. This will be 4. So the LCM will be 4. 2 into 4 into 3, which is 24. Which is 24. Okay. So now this will be minus 27 into 4 by 24 plus 3 by 24. This is equal to, why is it so big? I think at this stage you could have converted the rational number minus 27 by 6 to its standard form. That is, we could have divided both the numerator and the denominator with 3, and it would be minus 9 by 2. So let's not cancel this. Whenever you see any rational number that could be converted which is not in standard form, it is better. Sometimes it is better, sometimes it is not. Sometimes it is better to convert it to standard form before proceeding further. So I can convert minus 27 by 6 is not in standard form. So the standard form will be minus 9 by 2 after dividing both the numerator and the denominator with 3. Why 3? Because the HCF of 6 and 27 is 3. So this is now 1 by 8. So this will be minus 36 plus 1 by 8. This is minus 35 by 8. I hope it saved some time. Minus 9 by 2 plus 1 by 8 was easy to simplify or compute. Okay, what else? Let's do part 3 also. It has asked to compute or simplify, evaluate or simplify. Minus 13 by 20 plus 11 by 14 plus minus 5 by 7 plus 7 by 10. Now consider the rational numbers, group the rational numbers so that the HCF of the denominators is not equal to 1. So we can clearly see the grouping will be now you can say that you will group a minus 13 by 20 and 11 by 14. That is fine, but you are left with minus 5 by 7 and 7 by 10 and 7 and 10. The HCF is 1. So that grouping is not a correct way of grouping. So we will use minus. Whenever you do grouping, always remember that in each group, all the rational numbers, the denominators, the HCF of the denominators of all the rational numbers in each group should not be equal to 1. So minus 13 by 20, I will group this with obviously 7 by 10 because I have to consider 11 by 14 and minus 5 by 7 together. So this plus minus 5 by 7. So this becomes minus 13 plus 14 divided by, now I will skip a lot of steps. I hope you will understand what I am doing and why I am doing. So 11 plus minus 10, 14. This is equal to 1 by 20 plus 1 by 14. Okay. So now we have to find the LCM of 20 and 14. What is the LCM of 20 and 14? So 2, 10, 7, 140. So LCM of 20 and 14 is equal to 140. Okay. So this becomes 7 plus 10 divided by 140. This is 17 by 140. Okay. I think you can do the rest of the parts for problem 8. Let's move on to question number 9. The next few problems are word problems. The sum of two rational numbers is minus 2. If one of the numbers is minus 14 by 5, find the other. Okay. So the sum of two rational number is given and one rational number is given to be minus 14 by 5. So it is given that minus 14 by 5 and we will assume the other rational number as x. Now in books you will find instead of x it is assuming the other rational number is wherever any in this kind of word problems an unknown rational number is to be computed, it is assumed in the form of p by q or a by b, but it does not matter. It does not really matter, but it could be a nice convention to assume the rational number p by q because it looks good, because p by q is a form of a rational number. Usually x, y, z, these letters are used for all kinds of numbers. I mean all kinds of numbers. It can be integers, whole numbers, fractions, decimals. But if the problem is specific to rational numbers, then you can always use p by q as the unknown rational number, but I am using x. So it is given that minus 14 by 5 plus x is the unknown rational number, is equal to the sum of the two rational numbers is given to be minus 2 and one rational number is given to be minus 14 by 5. If I assume the other rational number is x, we have minus 14 by 5 plus x equals to minus 2. Now from this is a linear equation, one variable in x, and you have already studied linear equation in one variable in your previous class. I hope you will understand, you know how to solve this. X will be equal to minus 2 minus 14 by 5. So now this is subtraction of two rational numbers. We know that this will be plus 14 by 5 because why? The additive inverse of minus 14 by 5 is 14 by 5. This is nothing but minus 2 by 1 plus 14 by 5. And if you simplify this further, you will know this will be minus 10 plus 14 by 5. This is equal to 4 by 5. So the other rational number is 4 by 5. This was part. Okay, it has no part. Question number 10. The sum of two rational numbers is minus 1 by 2. Okay, the sum is minus 1 by 2. If one of the numbers is 5 by 6, find the other. One number is given as 5 by 6, and let us assume the other number be x. We have to solve this. So clearly from the concept of linear equation in one variable, you can say that x is equal to minus 1 by 2 minus 5 by 6. Okay, this is equal to minus 1 by 2 plus additive inverse of 5 by 6, that is minus 5 by 6. Now this will be the LCM of 2 and 6 is 6, minus 3 plus minus 5 divided by 6. This is minus 8 by 6. This is minus 4 by 3. Okay. Question number 11. What number should be added to minus 5 by 8 so as to get minus 3 by 2? This is the same problem as 9 by 9 and 10, but it is given in a different language. The problem statement is a little different, but the actual mathematical problem is the same. So we have this number minus 5 by 8. It is asking what number we should add to minus 5 by 8 to get minus 3 by 2. So that what number, the mysterious number, or the number we have to find, let that be x. So this implies that x will be equal to minus 3 by 2 minus 5 by 8. Now this is equal to minus 3 by 2 plus the additive inverse of minus 5 by 8, which is 5 by 8. So this is equal to minus 3 into 4 plus 5 divided by 8. This is equal to minus 12 plus 5 by 8. This is equal to minus 7 by 8. So what number should be added to minus 5 by 8? The number that should be added is minus 7 by 8. Let's do problem number 12. What number should be added to minus 1 so as to get 5 by 7? Now I will not solve it. The mathematical, if I translate this given problem, word problem, to mathematical statement or problem, it will be like this: minus 1, x is an unknown rational number. If I add x to minus 1, it is giving me 5 by 7. So I have to solve x. This is solve for x, where the given equation is minus 1 plus x equals to 5 by 7. I am not going to solve it. Okay. So basically question 12 is, which you have already done a linear equation in previous class. So this is the problem statement: solve for x. Minus 1 plus x equals to 5 by 7. So basically x will be 5 by 7 minus 1. Okay, let's solve it anywhere. X is equal to 5 by 7 minus 1. This is equal to 5 by 7 plus additive inverse of minus 1 is 1. This is equal to 5 plus 7 by 1 is going to take 1, 7. This is equal to 12 by 7. Okay. 13. What number should be subtracted from minus 2 by 3? What number should be subtracted from, let that number be x, to get minus 1 by 6? Okay. So now this time, if you are familiar with solving linear equation in one variable, you should be able to say what will be x. X is equal to minus 2 by 3 minus 1 by 6, because you will take the x to the right hand side and you will bring the constant term from the right hand side to the left hand side using the concept of transposition. I hope that is the word, transposition. You transpose terms suitably from LHS to RHS or from RHS to LHS to solve a linear equation in one variable. And when you transpose, you change the sign. When you transpose a term, you change the sign. Now what is this? Minus 2 by 3, additive inverse of minus 1 by 6 is 1 by 6. This is equal to minus 4 plus 1 by 6. This is equal to minus 3 by 6. This is equal to minus half. Okay. Problem number 14. These are all I guess, okay, so these are questions, okay. Part 1, which rational number is its own additive inverse? Which rational number is its own additive inverse? If you already know, I've already discussed this in the previous video, part 6, that 0 is the only number which is equal to its additive inverse. Now, if you want the proof, if you want to see why is it so, let's say the rational number let's say the rational number which is equal to its additive inverse is p by q. So I will have p by q is equal to its additive inverse of p by q, which is equal to minus p by q. This implies if I bring the right hand term to the left hand side, I get p by q plus p by q equals 0. This implies twice into p by q equals to 0. Now I know you will obviously say that p by q is 0, but why is it so? What is the mathematical concept? When you multiply, the concept is 0 multiplied by with any rational number always gives 0. 0 multiplied with any rational number is 0. Now, if you have something like this, question mark multiplied by a rational number p by q or whatever is 0, then you can obviously say that this question mark is 0. So, over here in this problem, the p by q is unknown. P by q is unknown. So, if I have this, we can immediately say that p by q is 0, and this implies that, okay, so this is 0. So, we have proved that the rational number has to be 0. Okay, part 2. Is the difference of two rational numbers a rational number? Yes, because subtraction of rational numbers is closed. That is, subtraction satisfies the closure property. Just like addition and subtraction both satisfies the closure property. What is closure property? If you add two rational numbers, what is closure property of addition of rational numbers? If you add two rational numbers, the result will also be a rational number. What is the closure property of subtraction of two rational numbers? If you subtract two rational numbers, the result will also be a rational number. So this is true statement. Part 3, is addition commutative on rational numbers? Of course, because we always have p by q plus r by s, where these p by q and r by s are into rational numbers, is always equal to r by s plus p by q. Addition is commutative on rational numbers. Part 4, is addition associative on rational numbers? Yes, of course, yes, we know, because we know that p by q plus, for any three rational numbers, p by q, r by s and t by u, this is equal to, we can, what is associative property, associative law? You can change the grouping of associative law of addition of three rational numbers. You can change the grouping. You can change the grouping of rational numbers. So we have this. So this statement is true. 5, is subtraction commutative on rational numbers? No, because we know that p by, for any two rational numbers, p by q and r and s, we can clearly say that p by q minus r by s is not equal to r by s minus p by q. This is never the case. You can easily find some examples and verify this. So 5 is no, subtraction is never commutative on rational numbers. Part 6, Is subtraction associative on rational numbers? No, because P by Q plus, not plus, minus R by S minus T by U is not, it is not necessarily be same as P by Q minus R by S minus T by U. This thing need not necessarily be true, because consider uh, because you can clearly see that LHS is equal to, if I open the grouping, P by Q minus R by S, it becomes plus T by U, which is not, and the RHS, if I open the brackets, grouping, it is P by Q minus R by S minus T by U. The LHS has plus T by U and the RHS has minus T by U. So these are, so the associative law of subtraction does not work. So subtraction is not associative on rational numbers. 7. What is the negative of a negative rational number? What is the negative of a negative rational number? So let's say, let the rational number be P by Q. This implies negative of minus negative of P by Q is equal to, you can just take the negative of the numerator, minus P by Q. This implies negative of negative of P by Q is equal to negative of P by Q. We know that it is minus P by Q. So the negative, if the rational number, let the rational number we have assumed to be P by Q. What is the negative of P by Q? It is minus P by Q. So we have to check, we have to find the negative of P by Q. So negative of P by Q is equal to negative of minus P by Q. Why? Because negative of P by Q is minus P by Q. So what is the negative of minus P by Q? This is this. So this is basically P by Q equal to the original rational number. So when you take the negative, so the negative of a rational number is always the same rational number. So this brings to an end of solving the problems, not all, but the major problems from exercise 1C that will give you a good insight and concept of how to apply addition, subtraction, and a concept of addition, subtraction of rational numbers and their properties, and the concept of additive inverse, additive identity, and all these concepts to solve this kind of problems. So I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video will be on discussion of multiplication and division and their properties of rational numbers, and the concept of multiplicative identity and multiplicative inverse. That will be the next video, and after that we will solve the exercise problems that is based on multiplication and division of rational numbers. So please stay tuned for the next video, and please also note that this is the first chapter of class 8 rational numbers I have started, and once a chapter is complete, I will parallelly start on the videos from the of the that will be videos related to concepts to remember, that will be in a separate playlist titled Concepts to Remember Maths 8, where I will only discuss the very key concepts, conceptual idea, formulas, and some tricks that covers the most variation of problems that you will be asked. So those videos will be very useful. Those videos are not meant to study for the first time. If you only see them once you have completed a particular chapter and you have solved quite a bit of problems. So those videos you can only it's better to use those videos as a checklist to see that your concepts of a particular chapter are up to the mark. So please get subscribed to my channel so that you will get the notification for all the videos based on concepts to remember. So thanks for watching, and until the next video, take care and bye.